Wonderful people from Jabu. I'm talking to 300 level class. I want us to start our lecture series on MLS 311, Introduction to Medical Laboratory Theory. Please, in this very lecture, I've sent you the note through your class rep already, the person of Nancy. Please, I want you to take note. We are just doing a revision of what we have learned in 200, Introduction to MLS2. But briefly, we will look at the course outline, but I think by the grace of God helping us, we're able to go through some of the course outline in preparation for your exam coming up by end of this very month. Please, I want you to understand that this very course outline, the part I'm taking is just consigned presentation of volumetry analysis. We also look at SI units. We look at some simple analytical techniques in chemical pathology. That ends my own part. And in addition, how to prepare a patient for various laboratory investigation. Please let me welcome you to a very bright and wonderful year 2024. Happy New Year to you all. This very afternoon, I want us to look at volumetry analysis. From the word volumetry analysis, in your chemistry days in secondary school, even at 100 level, you were exposed to volumetry analysis, which for short, the simple type you carried out was on acid-base titration. Now, if we say volumetry analysis, you can also call it titrimetry. Titrimetry is a quantitative analytical technique used to determine the concentration of a substance in a solution. Please take note of that. Analytical techniques used to determine the concentration of a substance in a solution. I want you to understand that this method relied on measurement of volume of a reagent. We want to measure the volume of a reagent, that is a known against the unknown. That the known is called the titrant, while the unknown is your sample of interest, your sample of analyte, sample of consigned. You want to determine the actual concentration. That is what volumetry analysis is just all about. That is titration is all about. Please take note that this technique called volumetry analysis is very versatile and is widely used techniques in analytical chemistry, providing precise and accurate measurement of the concentration of the substance in a solution. Please don't forget what a solution is all about. If we say solution, we are saying that it is a homogeneous mixture between a solute and a solvent. I believe you know what solutes are. Solute substances that can dissolve. Why a solvent is a dissolving substance, that is, it has the ability to dissolve a solute. Example is water, which is we refer to as universal solvent. Solvent can be polar, it can be what? Not polar, as the case may be. A polar solvent like water, while not polar like organic solvent and the rest. These substances can help to dissolve a solute when present in it. Now, what we are trying to do here in volumetry analysis, we want to measure the standard against the unknown by reaching an end point using an indicator. And by way of doing that, we can say that an end point has been established, and hence we can calculate the volume of the unknown substance in that very solution. That is volumetry analysis. Quickly, we want to look at the basic principle that governs volumetry analysis. Number one is the chemical reaction. The chemical reaction between the titrant, which is the known substance, and the analyte have to occur and then there have to be an equivalent point. That is second principle guiding it. If we say an equivalent point, what are we referring to? It is the amount of titrant added stoichiometrically equivalent to the amount of the analyte at that very present. Now, what am I referring to? I said the point at which the amount of your known concentration of a solution is added stoichiometrically equivalent to the amount of the analyte. Please understand that for we to say stoichiometric analysis or stoichiometric reaction, we are referring to equivalent or reaction between your reactant. Let me just put it that way: your reactant giving rise to a product. Are you with me? When there is reaction, there is bound to be what? A product in your chemistry. And remember that this very end product we are looking at is being the end product is being established. To know that the end product has been formed, you need to use what is called an indicator to establish that very process. But in a very simple example, like your acid-base titration, you make use of a known acid or a known base against an unknown acid or unknown base, thereby reaching an end point which we call equivalent points. Now, by way of refreshing your mind, I redefine what equivalent point is all about. Please take note. I say it is the point at which the amount of your titrant is added stoichiometrically equivalent to the amount of the analyte present. Please understand that when that happens, there is an indication that there is completion of reaction. There is completion of reaction. Please, I said for that to be visible, there is a need for you to make use of an indicator. Therefore, what is an indicator? Indicator are substances that change color at or near equivalent point. Please take note of that. Please understand that in your chemistry, we make use of different type of indicator: methyl orange, phenolphthalein, and what have you. These are substances that change color at or near the equivalent point. The essence of this in acid-base titration is to visualize the signal of the what? Of the endpoint. Now, there are other things you can do. After determining the endpoint of your acid-base balance, for example, there is a need for you to plot a graph, which I believe you all know in your chemistry. We call it titration graph. Titration graph have to be plotted. The essence of this very graph is to help you to determine the equivalent point and select a suitable indicator. That is the essence of what? Of your titration curve. Now, we want to move quickly to different types of titration, volumetric analysis, or you call it titration. Number one, we have the acid-base titration, which is very, very common to you and which you have been exposed to in your days of chemistry. Now, why we are saying this in clinical chemistry, because we still carry out titration on daily basis in clinical chemistry. Like in the case of acid bicarb estimation, we call it bicarb estimation. You still carry out titration to determine the amount of bicarb present in your blood. The amount of bicarb present in your blood. That is for bicarb estimation, where equipment are not available. Please, can you take note of that? Where the necessary equipment to do that is not available, you can still carry out titration, acid against balance, acid against what? Against base, so that the endpoint or your amount of bicarb in the blood can be established. Now, that is for acid base. Please understand that it involves neutralization reaction between the acid and base, and the pH indicator we use here, methyl orange and phenolphthalein, are commonly used in your acid-base balance. Now, let's look at the second type of titration we call the redox titration. This based on the principle of redox, oxidative, and oxidation and redox reaction. Please understand that when a substance try to give out an electron, is oxidized. Then when the substance receives an electron, it becomes reduced. The reaction that occurs between giving and receiving is referred to as what in chemistry is called oxidation reduction reaction, which is redox reaction. Here you can carry out titration using a redox oxidation and reduction substances, and by way of doing that you arrive at a given point. Please don't mind me. Now that is for that, and most of the titrants we use in this very redox reaction is potassium permanganate and sodium thiosulfate. These are basic known concentration you can make use of, known concentration of a substance you can make use of in redox reaction. The next type of reaction titration is the complexometry titration. What is it all about? It's the formation of complex between the analyte and the titrant. Please, when I say titrant, I'm referring to a known standard solution. A known standard solution. That is your titrant. Please take note of that. And this type is used for mental ion determination with EDTA as a common titrant. Please take note of that. We are using EDTA as a common titrant. Now, don't forget we are talking about complexometry titration, whereby there is reaction whereby there is formation of complex between the analyte and the titrant. And what happened here, I said we use it to determine ion concentration when we are using EDTA as our known standard concentration. Now the next one is precipitation titration. What happens here is that at the end product there is formation of precipitates. There is formation of precipitate as the end point. Unlike when you are using your methyl orange, your phenolphthalein, and so many other indicators to check the endpoint of acid-base titration. No, in the case of precipitation titration, what happens here is that the endpoint is visible when there is formation of what? Of precipitants. And that can tell you that you have arrived at the endpoint. And one of the common things we use this for, silver nitrate, is often used for chloride ion determination. Please take note. We use the silver nitrate to determine chloride ion estimation. Quickly, we want to look at some of the parameters we can make use of. I think this is just to refresh your mind. While doing titration, there are basic things you need. Number one is your burette. You need your burette. You need burette. Not only that, you need pipette, and not only that, you need some volumetric flasks. These all have different functions. They all have different functions. They all have different functions. I believe you know that very, very well. Now, to move further, let me quickly explain the procedure. The procedure involved in volumetric analysis. Number one is for you to standardize. The titrant concentration is determined precisely by titrating it against a known standard. A known standard. Number two, you have to carry out the titration itself. The analyte is titrated against the standard titrant until equivalent is what is reached, and then you do your calculation. Please understand that the calculation we normally do in chemistry then is M1V1 equals to M2V2. Please, you understand what I'm referring to. The molarity is equal to the mole of a solute over the liter of a solution. When the number of mole is equal to 1, you now have M1V1 is equals to M1V1 is equals to N, which is the number of mole. Are you with me? The number of mole. But if the number of mole is equals to 1, that shows that it is constant. You can also have M1V1 equal to M2V2. From there, you'll be able to calculate the volume of the unknown, either base or acid, as the case may be. Now, quickly, let's look at some of the errors that we can encounter while carrying out volumetric analysis. Number one is an error due to paralysis. Misreading the volume on the burette or the pipette, and not only that, titration endpoint incorrect, identifying the endpoint due to poor choosing indicator. If, for example, your indicator is not too clear and then you choose a poor indicator in that very process, you may not be able to ascertain when endpoint you have get to endpoint. That is why the right thing must be done. You must follow the right procedure for you to get accurate and precise result. Now let's look at another factor or source of error is titration rate. Adding the titrant too quickly or too slowly can affect your accuracy. I believe all these are things we normally do in the laboratory. By the time you are adding your axis to your base and you do it too quickly, you may have incorrect result. If you do it too slowly, you may arrive at the end point quickly, even when it ought to have, not to have get to where an end point. That is, all these are sources of what now? Errors in volumetry analysis. Please, I recall quickly in summary, factors that bring errors in volumetry analysis is 1. Error due to paralysis. 2. Titration endpoint. That is, the right indicator must be properly chosen for you to reach a good endpoint. And thirdly, titration rate. How quickly or how slow you do your titration can affect the accuracy of your result. Does it have application in laboratory medicine? Yes, it does. Number 1, it helps in clinical chemistry in determination of your blood glucose level, even cholesterol. You can use all those things. Titration can happen. Even in bicarb, you can use it, which I've mentioned earlier. In environmental analysis, you can use it to monitor pollutants in water and in air. In pharmaceutical company, you can even use to assess the concentration of active ingredients in your medication. And not only that, even in the food, we can use it to do our quality control in determining the nutritional content of that very food. Please, this is what presentation of volumetry analysis is all about. Please ensure that when you have to carry out this in your practical, which is your acid-base titration, complexometry titration, redox oxidation reduction titration, or which you call redox titration, and precipitation titration. Please don't forget there are principles guiding this: principle of chemical reaction and the principle of equivalent point. Please understand that. This lecture, I want to move further by looking at SI unit. Please understand, in clinical chemistry, we cannot do without presenting our result in standardized international units, which we call the XI what? XI unit, the systemic international unit. The measurement of various substances in biological samples such as blood, urine is crucial for diagnosing and monitoring disease, and these results are often reported in standard international unit. Please understand, which provide a global recognition and consistent system of measurement. Please understand that the essence of SI unit is to confirm global recognition. If I say that the glucose level of a patient is 20 milligram, it is internationally accepted. Whether you do it in UK, you do it in Nigeria, you do it in Dubai, you go ahead to do it in any part of the world. That is a recognized unit. Yes, we have to recognize unit. Either you use milligram per dl or you use millimole per liter. Please take note, millimole per liter or milligram per dl. Please, that is what XI unit is all about. I said it confirms on our measurement global recognition, and not only that, consistent measurement of our analyte present in every solution. Now we move further by saying understanding the SI unit in clinical chemistry is very essential, important, pivotal for healthcare practitioners. Not only that, for researchers, for laboratory personnel like you upcoming, and not only that, it also involved in the diagnosis and management of various medical conditions. Please take note of that. Now, that is the importance of XI unit. What are the basic things you need to know under this very XI unit? There are a lot of it. The basic SI unit in clinical chemistry. Let me, for example, I want to measure mass of a substance. I do that in gram, preferably in gram. weight is measured either in gram or in kilogram. Are you with me? But basically we do it in gram, in milligram, in microgram, in picogram, and just like that as the case may be. But the gram is the standard unit of mass. You can also do it in kg. Please understand there are other things you can do that way. Even the volume, we can measure volume in liter, that is standard, and you can do it in mils, you can do it in microliters as the case may be. Now you can also measure your time in seconds, that is the unit of time, in seconds. That is why 60 seconds is equivalent to 1 minute. You will now say 60 minutes equivalent to 1 hour, just like that. And the amount of substance in a solution is measured in mole. That is why we can say that millimole per liter or mole per liter. That is the amount of the substance present per liter. Please understand, these are units. Any measurement you carried out in clinical chemistry without a unit is no result, is nothing, is nonsense. That is why as a clinical chemist, you must be able to measure and present the unit at which that substance is what is mentioned. Now, quickly, I want to give you some common analytes and their SI unit. It's already there in your note. I have sent a common one and how to make use of this very analyte. Let me start with glucose. Glucose can be measured in millimole per liter. Millimole per liter. That is the standard unit. Millimole per liter. That is the standard SI. Millimole per liter. But you can take it to where? To milligram per dl, which I have done with you guys when I was over there in Jabu by way of doing some calculation, converting from millimole to milligram and from milligram to millimole. If you are to convert from milligram to millimole, you want to convert milligram to millimole, all you need to do is to divide that value by the molecular weight of glucose, 18. Are you with me? Because the molecular weight of glucose is 180. There is a formula I gave to you. But if you now say milligram per dl, milligram per dl is just equal to the millimole times 180, which is millimole per liter times 180 over 10. Are you with me? That gives you, that is times 10 over 18, times 10 over 180. That gives you in millimole per liter, when you do the cross multiplication. Please don't get confused. If you are not clear with this very point, better chat me up, ask me a question on regard to this, so that I can clarify you. But I recall by explaining that again. I said the formula, I want to convert from milligram to millimole. All I need to do is to put up a formula that says milligram is equal to, milligram per dl is equal to millimole per liter times 10 over 18 times 10 over 180. When you do your cross multiplication in millimole, it will now be milligram divided by that what? By that 18. Then you have your value. Please, that is for that. Cholesterol as well can be measured in the right unit as millimole per liter. The ranges are there. Even the creatinine as one of our analytes can be measured in micromole per liter. Now, even your hemoglobin concentration can be measured in gram per deciliter. Gram per deciliter. Please take note of that. Even your sodium is measured in millimole per liter. Potassium in millimole per liter. Just like that. Your calcium is measured in millimole per liter. These are standard SI units. In your notes here, I've been able to give you some ranges of this. Even thyroid stimulating hormone is measured in milli-unit per liter. Milli-unit per liter. Just like that. Even the conversion factors is right stated there, even in your note. If I want to convert from gram per deciliter to gram per liter, is to multiply by 10. Is to multiply by 10. If I want to convert from milligram DL to micromole per liter, is for creatinine is to multiply by 88.4. And creatinine conversion, you can do it either in micromole per liter or in micromole per liter or milligram per DL. Now, even to convert your glucose, I said divide it by 18, you get that. Please understand that in reporting and interpreting your result, it must be within a range. It must be within a range. Please, when I come around, I will talk about how to determine a range. And please get ready for that very explanation. How to calculate a range of a given range of a sample. If you are asked to establish a reference range between the population, I will be able to do that. But with this very video, I will not be able to do a calculation through this very medium. But by the time we are talking on how to establish a reference range, we will do that by explaining it together. Please take note of that. Now quickly, I want to move on to the next topic I added here, which is of importance, which I call preparation of patient for laboratory investigation. Please, may I let you know that a lot of scientists, those that are qualified and those that are still on training, are not exposed to this very topic. It's not in your curriculum, but I feel it's important for me to add this to it so that you understand how to prepare a patient for every laboratory investigation. When a patient walk up to you, I want to run this type of test, I want to do this investigation, you should be able to let the patient know what and what he or she must do so that your result will be the best. Your result will not be affected by different kinds of interference, let me put it that way, either from diet, either from medication, or from other external factors that can affect your result. Because the quality of your results starts from where? From sample collection and the education you provide to your patient on how to do every process so that your result. Now, to start with, preparation of patient for laboratory investigation is important to obtain accurate and reliable results. Different laboratory tests may require specific preparation to ensure that the result reflects the patient's true physiological status. Proper patient preparation is essential for obtaining accurate results, which I have said earlier. Please understand, this is not only to enhance the accuracy of results, but also to contribute to the better patient care and proper medical decision making. Please, may I stop there? What I've just explained now is that your patient need to be well prepared. It's not just to get a reliable result, but for the better patient care. When a patient is well prepared for investigation, the patient is going to recover on time from that very hospital, from that very bed, from that very laboratory, and yes, regain his wellness very, very fast. But in the case whereby a patient is not prepared and you give out a wrong result as a result of that, at the end of the day, all things will not go well, and it will also tell back on you as a laboratory scientist. Now, quickly, I will mention some investigations and also the laboratory preparation for that investigation. Now, let's look at one of the way to prepare is fasting blood test. Fasting blood test. I always tell patients that they should come fasting in most of the clinical chemistry investigation. Please take note, I say most of the clinical chemistry investigation. Why? Because the system is free, no interference with the analyte of interest, and you get an accurate result, and that gives the patient a good patient care. And not only that, it makes the medical doctors or the clinicians to have a good decision making about patient management. Now, let's look at it further. Some of the tests involved. If I say come fasting, I will quickly mention one. One is your fasting blood sugar, as the name is called, fasting blood sugar. You can't come fasting, you can't come to a fasting blood sugar and you have taken a tea, or patient have taken one Lipton or one other liquid, you will educate them not to take anything. Because if you tell a patient to drink only water, he may take tea and tell you that you have not eaten, and that has defied the purpose of your investigation, because patients are not always truthful. It is of best interest to tell them to avoid all things and come fasting. And the fasting we are talking about here is overnight fasting, which is about 8 to 12 hours. Please also take note that fasting is different from starvation. When someone comes to your laboratory and from 10 o'clock he said he's coming for fasting blood sugar, that is no longer fasting. That person is what? Is starving. I'm telling you, he's starving. Because let's say for example, the person eats around 6 p.m. in the evening and is coming by 10. Already from 6 to 6 already 12 hours. 10 to that 10 o'clock is already making it what? 18 yes, 18 to 16 hours, and that is no longer fasting. The actual time of fasting is 8 to 12 hours. Please pardon me, it's 8 to 12 hours, and that gives you an accurate result. Water should be allowed, but confirm with the healthcare provider. Water is allowed. Water is allowed. Please, I said earlier, it's better you tell the patient not to take anything than to advise them to take only water, because they may drink tea and tell you it is fasting, and that can affect your what? Affect your result. Now, there is a test called glucose tolerance test. We have explained that a little in your MLS 313. Yes, 313, that is your clinical chemistry. That type of test, you should come fasting, and you know it's mainly used to diagnose diabetes or gestational diabetes. Preparation is to fast 8 to 12 hours, and the patient, when he arrives the hospital, you are to collect their FEC sample, and then you give them a standard glucose dose of about 75 gram solution to take. After 1 hour, 2 hours, as the case may be, you sample their blood to check. But anyway, I'm not explaining glucose tolerance test. All this we have established before. Now, urinalysis also. The urinalysis text involved, we are talking about assessments of kidney and urinary tract. Patients should also come, not actually fasting. In cardiac urinalysis, patients should be advised to avoid certain food that can affect result. Like a test urinalysis, someone is taking vitamin C. It's not okay. Vitamin C can give you a false positive result in urinalysis. Patients taking a lot of things coming for urinalysis test, your result can be actually affected. Also advise them. Now, cholesterol. Someone is to do a cholesterol investigation. The person should come fasting, 8 to 12 hours fasting, because if that person go ahead to eat a food that contain fat, high fat meal, that shows that the result will also be affected. And not only the alcohol as a medication, you don't take alcohol while coming for cholesterol investigation. Even let's look at the full blood count we run in hematology. Anyway, there is no special preparation for full blood count. We don't need special preparation. Please take note of that. Please tell the patient to come whether I eat or not. It doesn't have to affect your what? Your full blood count. Now let's look at thyroid function test. Thyroid function test, such a person for certain tests like TFT, you have to come fasting. Please understand, in thyroid function test there are 3 parameters. We have the thyroid stimulating hormone, we have the tyrosine himself, and we have the triiodothyronine, which is the T3. Please advise the patient to come fasting, not because of the thyroid stimulating hormone, not because of T3 or T4, but specifically because of what? Of TSH. Such person will have to come fasting for a better result. Now let's look at lipid function test. You know, you will have to do ALT, AST, ALP, bilirubin, albumin. Please understand, not usually required. You don't need to prepare for this very investigation. But for you to carry out lipid profile, which I've mentioned earlier, the person must come fasting. Imagine a test is having LFT, and LFT and is having FLP, which is fasting lipid profile, for one patient, how will you advise such a patient to prepare? Because in liver function test there is no preparation, and in LFT there is preparation. What do you need to do? Which means there is a need for you to make the patient fast for both investigation, because one require fasting and the other require no fasting. But if you decide to say no, the patient should not fast because LFT said you should not fast, what is become the outcome of the FLP? And you are not going to sample these two on two different occasions. That will not be too good for the patient. Now, like a coagulation study, there is no special preparation for it. If I say coagulation study, you will be talking about prothrombin test, activated prothrombin, activated partial thromboplastin, and so many other investigations. Doesn't require any kind of preparation. And electrolyte also does not require any kinds of preparation. But if electrolyte is together with anything that require fasting, please take note, the patient will come fasting. Now, hormonal acid, like in the case of cortisol, I said earlier, cortisol is affected by the time of the day. Is affected by the time of the day. Please, I want you to take note of that. Is affected by the time of the day. Please take note. There are various tests, your cortisol, your insulin, your sex hormone. It's affected by the time of the day and even the period of the month. Are you with me? If you are just, it's better to run a cortisol investigation 2 hours immediately after waking up. You run that very investigation. But after you have undergone a stretch for the day and you are coming to run a cortisol value in the evening, you are giving out the wrong result. That is not the best time. Imagine someone that is having a issue with his period as a female, or is having issue, cycles are not balanced, up and down, just like that. There is a specific time you need to pick up a blood sample for sex hormones, especially day 3 and day 21, because of progesterone. Are you with me? Progesterone will be key for that. Day 3 of your cycle, day 21 of your cycle. These are the two specific days that you tell the patient to come for such investigation for progesterone. Now let's move further. Please, for general guidelines for patient preparation, there should be proper communication, counseling between you and the patient. Patient should be informed about the specific requirement for each test. That is what we are trying to discuss here. You must communicate. You must educate. I want to say, is it what you don't know that you can't give what you don't have? That is why you must take this knowledge to heart and understand various investigations that is of importance for you to educate your patients so that they will have the best, so that you yourself will be at a safer side by giving out a good result. Not only that, you must be able to tell your patient medications to avoid for various kind of investigation. Thank God you are handling pharmacology now. You should be able to know various drug routes of administration, and so many things drug can cause to the system, and how to avoid these drugs when it comes to interference with your investigation. Please take note of that, especially alcohol. Alcohol can interfere with a lot of investigation. Now, another factor you must be able to tell your patient is hydration. Drinking the water is often encouraged unless specified otherwise. Tell your patient to drink enough water, but not with any additive, not with Lipton, not with any additive. Please take note of that. Now, as a scientist, you must be able to do your proper documentation of your patient preparation to ensure reliability of your result. Please take note. Take note of that. Take note of that. Please, I want you to take note. With these few points, I will want to end this first phase of this very class at this very point. Then we are going to continue with the second phase, lecture series 2, any moment from now. Please feel free if you have any question, any confusing area in what I have discussed in the course of this very lecture, please try to bring it up so that we look at it together. What I've just looked at by way of summary, I've looked at volumetry analysis, I've looked at SI unit, I've also looked at preparation of patient for laboratory investigation. Before I will round up this very lecture, how do you prepare a patient for occult blood test? Let me quickly chip that in. A patient that is coming for an occult blood test should not eat vegetable, should not eat meat for a period of 3 to 5 days. For 3 to 5 days, such a patient should be well prepared so that any issue that we have to resort to, because when you eat meat, there is bound to be presence of blood in that very stool. Please take note. Now, quickly, let me chip in someone that will come for semen analysis. When someone is coming to, they must educate the patient to be prepared. How? One, the patient must not use condom for what? For collection of semen sample. That is a good knowledge. Tell your patient don't use condom, and don't you, if you must do coitus interruptus. What do I mean by coitus? Which means trying to ejaculate, you withdraw. That is coitus interruptus. You must be able to tell the patient to indicate it in the bottle, or should be able to explain it to the scientist in charge. And also the time that sample will get to the laboratory must not exceed 1 hour. And if you exceed 1 hour, that can affect your result because the level of motility must have decreased. And not only that, there are a lot of investigation, like as a scientist giving a swab stick to a patient to collect their blocks, to collect their high vaginal swab is wrong. Why? Because they can decide to pick up the surface, which can give you a normal floral growth, which will not be significant. Please, I want you to take note of all these key things. Now, I want us to go back and look at it one and study our books, go to library, check up factors that can affect result. Please, I want you to go back and check on medication. That as a form of assignment. I may set it up in form of your exam, enumerate, list out some basic drugs that can affect this type of investigation, Please take note. I am giving it out as an assignment. I want you to submit that very assignment. Drugs that can affect various kind of investigation. Please, I want to take note of it. In way of summary, we are coming to lecture series 2. Try to put this very knowledge down. Ask me question, then I will be able to explain. I'm online on Facebook. You can ask on WhatsApp. You can ask, send your main question. I will be able to answer. Then even on YouTube, you can send your question. Fine, the answer will be provided. Thank you very much for this very lecture. The subsequent lecture will be coming soon. Thank you. God bless you.